So it's therefore a great honor and pleasure to be speaking at, to be invited first and to be speaking at your 80th anniversary. So I thank the head of the department and all my, should I say, friends in IIEST for giving me this opportunity and sharing this honor with me. So I'll be speaking today on challenges and opportunities in materials in India. And I'll be focusing on India, and I'll be focusing on why we need to sort of step back and have a relook at things today. I mean, these days, especially when most of us are forced to stay indoors and speak over the internet with very little travel, very little person-to-person interaction, gives time for introspection. And this talk is more of an introspection on a wide materials field. So please, you won't get bored by any one particular area. So I was listening to the question answer session of the last talk, and I was in a way feeling happy that I was not the person of the receiving end, because I would not have been able to answer any of the questions. So in a way, my talk is more general. It is more from a policy, from a directional point of view, but I'm sure the students and the faculty members will find this enriching, and also in terms of point of view, would give you some new ways of thinking and a new directionality in perspective. So here goes. So again, congratulations to IIEST Metallurgy Department, Metallurgy and Materials Department for their 80 glorious years. So, and thank you for having me here. Let me check. Can you hear me clearly?
Yes, sir.
You are completely fine. Completely fine, you are, sir.
Thank you.
Yes, yes.
Okay. So, there are transitions that happen and disruptions that happen as one goes along. And it is not a fiction that from time to time when disruptions happen, one needs to step back and introspect, look at things and assess and make course corrections. So this is an example from Hyundai. I don't know if you had noticed this ad before, but I've used this in 2 of my talks before. So some of you who have seen this, please bear with me. So this is Hyundai, which we know is a very, very, very famous and commonly seen car company. Says once upon a time, Hyundai was a car company, right? And it goes on to say that car itself, automotive or mobility, is going through a transition, disruptive transition. The future of mobility is completely different from what we are used to. It is shared, it is connected, it is clean in the sense that it is not using oil, it is using batteries and green electricity. It is more automated, and therefore the car company sees itself not just as a manufacturer of cars. It is seeing itself, and you look at the bottom of the slide, it says, in short, we are becoming a smart mobility solutions provider and not just a car company. So they have seen the change coming, they have introspected and they have course corrected, and they've positioned themselves in a new paradigm, so to speak. These things keep on happening, and if a person or a company or even a nation doesn't make these course corrections, doesn't react to the things that are happening around us, that entity is in a way doomed to fail, because the writing is always on the wall. So here's an example. So we, again, before COVID times, when we used to travel, we often used Expedia or Booking.com or services like that. They were just one-stop shop on the computer, which handled all your travel, all your hotels, your rental cars, everything. And of course, once that happens, you would not go to a shop of Thomas Cook and buy a ticket across the counter, or take the trouble of asking a person for hotel reservations and so on and so forth. And Thomas Cook's share prices reflected that change in behavior, reflected that change in technology that was happening. But Thomas Cook did not take corrective action. And the inevitable happened. So while the writing was on the wall since 2008, 2009, they took no course correction and they disappeared in 2019. Of course, Expedia probably didn't foresee COVID. It'll be interesting to see what happens after this disruption to platforms such as Booking.com and Expedia, when people, I think, for the next 1 year would find it very, very difficult, and also would resist themselves from traveling. So that story is still to unfold. So let's talk about the current situation, the COVID, and this is a cartoon from a magazine called The Economist, and this came out in April sometime. It's a weekly, so it's one of the weeks in April this came out, and it shows that on the one side of this COVID calamity, if you wish, is the virus, and on the other side, which has a lifeline, the person thinks, is debt. In order to overcome the after effects of COVID, nations and companies will be in heavy debt. So that was the view in April. And of course, as we are progressing through COVID, we are seeing that debt is not the only fallout of COVID. And in many areas, the fallouts are quite unique, are pertinent to those areas. So we will see some which are pertinent to the materials area and also pertinent to India. So here goes. So some of the post-COVID realignment, if you wish, are the following. There is a clear change from globalization to localization. Trade barriers have gone up. Politics across the world is changing, largely fueled by the uncertainty on the source of the virus. And of course, one thing leads to the other. So localization is here to stay. We saw the importance of medical materials, and I'm going to talk a little bit more about it, how as a nation, India was caught on the wrong foot. And it is absolutely imperative for us to be self-reliant in medical materials, medicines, and all that sort of stuff. It is important that we have independence in energy. And as we see investments being poured into infrastructure across the world, whether it is USA with its trillions of dollars, whether it is Europe with its $0.8 trillion, or Japan, or what have you, the investments are going consciously into green economy. They are not putting money in to rebuild old stuff. They're building new stuff which are greener, which are more sustainable, and therefore environment is still, we had thought that it would go back in the agenda. It is still top of the agenda. In fact, it probably has come back with renewed vigor. Even in USA, the amount of money and grants that are being poured into research into hydrogen, etc., is lip-smackingly I feel envious at the numbers that are coming out from the grants for hydrogen, etc. So let us look at medical materials and devices. Yeah. So if you remember, the photo on the left was something that was being printed, published in newspapers right at the early parts of the COVID situation, where hospital staff, in the absence of proper PPE, were wearing or were given to wear raincoats as PPE. And of course, as we learned, as the nation geared up, either through imports or through re-gearing up, realigning the textile industries and other industries, we got there. We got the PPEs in numbers. But precious time was lost, and I'm sure precious life was lost too. But importantly, there was a lesson. The lesson is that we were not prepared with adequate PPE for our need. And The next slide, this one, I'm going to check whether you're still able to see the slides.
Yes, yes.
Okay.
We can see clearly. No problem.
So this highlights a little more detail about what the story that was made in the previous slide, the inadequacy of infrastructure. So if you look at number of doctors per 10,000 population, India is below global average. Again, don't take these numbers as absolutely sacrosanct to the decimal. They are, if you look at different sources, you'll get different numbers, but these are indicative. So in terms of orders of magnitude, the number 7, maybe 5, maybe 9 in other publications, the 30, maybe 25, maybe 40 in other publications. But this is in general the order of magnitude difference. And this is the global average. Imagine, this is global average, not just for the first world countries. This includes Africa, right? Insurance coverage, we are far below. Health spending, we are far below. Our market size, which means the world is $300 billion market. We spend $7 billion. That's because of our ability to spend in health, or inability to spend in health, and hospital beds. In each of these counts, we are found wanting. And of course, this also means that as we progress, as India grows in GDP, as consciousness grows, as the need to be self-reliant grows, these numbers are going to move up. And there's going to be a huge need to fulfill this gap. And this is not only from the need of those numbers, but it's also a need from the health demand that's coming from the nation. So by 2025, for example, India is going to have 160 million plus people who will be above the age of 60. So India will have a large number of people who will need old age care. Of course, 60 is not old anymore, but as the population grows older, the nature of care changes, the quality of care changes, and that will need to come in. We are a nation full of lifestyle diseases. Essentially, we know because of our food and because of our lack of exercise. So 82% is the percentage amongst all diseases amongst people in India, which are related to lifestyles. So 47 million plus people are heart patients. 45 million plus people are diabetes patients. These are huge numbers and a huge burden to the country. So on the one side, you have an infrastructure, which I showed in the previous slide, which is lacking. And on this side, there's a demand which is growing. And that needs to be bridged. And it is absolutely essential for us as a nation to be self-reliant, to bridge this gap. And I'm just going to show you one aspect of bridging this gap, which is medical devices and materials. So I'm not going to talk about medicine. I'm just going to talk about medical devices in 4 segments of diagnostic imaging, instruments, appliances, patient aids and implants, and consumables and other stuff. If the devices can be grouped into these 4 categories, and if you look below on the blue rows, you'll see the business volume in India. So the total is about $8 billion worth. Most of these materials and devices are imported. Diagnostics and imaging, 66% is imported. Instruments and appliances, 80% imported. Patient aids and implants, 70% imported. Consumables and others, 45%. Of course, these are the easiest of the devices and materials, and also of the lowest margins. So bandages and suturing materials, they're more and more in India. But all the high-tech stuff, the first 3, are majorly imported. And if you look at the nature of this industry, there are 750 manufacturers in this space in India, in medical materials and devices, out of which 95% have annual turnover below 150 crores. And they're just really small companies. 95% out of 750 are small companies. And needless to say, that the Indian manufacturers, the quality is low and it's inconsistent. And therefore, they are not able to compete with the quality and the consistency of products that are being imported, although the imported material is of higher cost. The Indian manufacturers are just not able to match up. Even simple basic material like hydroxyapatite is imported. And just to give you show you the importance of hydroxyapatite, this is where hydroxyapatite goes. It is sort of a bone material. So it goes in the head area, in the maxillofacial, in the femur, in the spine. It's one of the most commonly used orthopedic dental material. And we don't make it. We import. Look at hydroxyapatite, right, which is most commonly used orthopedic material. If you look at the knowledge and value chain, right, you need basic knowledge for any material, which exists. I mean, if you go to IISc or IITs, there are many groups, eminent professors who know and who work on hydroxyapatite. There's absolutely no dearth of knowledge. If you look at pilot capability, where you take that knowledge, you take hydroxyapatite and make prototypes, there's again plenty of capability available in India. You have NML, you have CTCRI, and I'm sure there are more who also work with hospitals to make prototypes from hydroxyapatite, and it's hard work. The material is also hard. It's hard work, but they have done it. They've done it over the last 10, 15 years or more even. But this is where the problem is. The problem is when this prototype needs to be manufactured, we don't have scalability or large manufacturers with reliability in India, which take this up and take it to scale. Somehow that has always been missing. There is a need here to have a stronger tie-up between the piloting laboratories and a large-scale industry to come and take this up to scale with reliability and the right quality standards. On the other hand, there needs to be a strong link between this manufacturing industry and the hospitals and the users, who are the doctors, to make sure that the material and the devices that are coming out are up to date and solve real-time problems for the user. Right at the end of the chain, again, India has a growing demand. It's a huge market, so it's a thumbs up. So somewhere in the middle, this chain is broken. And I feel there are two issues here which need to be addressed, and both can be done through policy intervention. One is the way medical device is defined in India. It is defined as in the same way as a medicine. So the certification process is the same as that of a medicine, which takes a long time and and is a deterrent for large companies to come in and spend all that money and time, more importantly, to get one particular device or material certified, which is not a medicine. And the other part is stronger tie-up between these two steps of pilot and manufacturing, between the labs and a large-scale industry. So I will leave that story there, and I'll move on to some other sector to look at how that is faring in an India that needs to be self-reliant in the post-COVID world, in a world that is becoming more and more localized. And let's look at aerospace. So this is how the materials have moved or are moving in the aerospace. And this is just one example of passenger aircraft, looking at Boeing series 747 up to 787, and Airbus A380, which is being phased out, and A350, which is the new kid on the block. And you will see that there is a large increase in the use of composites. And these are mostly carbon-based composites, carbon fiber-based composites. And concurrently, there's an increase in the use of titanium, because the bonding between composites and titanium is much better than bonding between composites and aluminium. So aluminium, you can see, has taken a dip. Titanium has risen, and so have composites. And this is a trend that is reflective not only in domestic, in civilian aerospace, but also defense aerospace, which have more use of composites. So let us look at where India is in the aerospace defense sector in two critical materials such as titanium and carbon fiber. So titanium, India's a third or fourth largest in terms of deposits of titanium ores, ilmenite and rutile. India makes 500 tons of titanium, and the world makes about 75,000 tons. So India makes, therefore, less than 1% of world's production. And no wonder that it is suboptimal. It is suboptimal. Its full economics doesn't work out. You can see the cost is $22 per kg, whereas the international price is $9 per kg. There is a magnesium recycling that needs to be done and to extract the magnesium, but that cycle doesn't work. The scales don't work. So India is struggling in titanium, although it is the third or the fourth largest raw material holder for titanium. And where is the problem in this material? And again, if you look at the value chain, you'll see that in terms of basic knowledge, it exists in pockets. It probably exists in Midhani, it exists in, which also has pilot capabilities. It exists in IREL, which has put up the 500-ton plant. But if you look at academia, there are no large groups that are working on titanium. If you go to China, you'll probably have university dedicated to titanium. That is the difference. In terms of manufacturability or manufacturing capability, we just discussed, there isn't much. And in terms of usage, the market is low. We have not invested in developing our own internal aerospace, either domestic, either civilian or defense. There have been efforts, there are long-term efforts, but they have remained as efforts. They haven't come out as large-scale Indian products. So it is absolutely, there's sort of two things need to be done. There needs to be a market pull. As a nation, we need to say that, look, if we have to be self-reliant in certain key sectors, we need to invest in the end product. We need to have our own defense aircrafts. We need to have our own civilian aircrafts, which will then pull the rest of the material. Till that happens, of course, there is a global market, and we can be competitive in a global market if we have the capability to make at scale with reliability, and of course we have a wage advantage. So we with reliability and scale, we will probably be beat the rest of the world on cost. So we need to build the market pull, and we need to have a vision to make in India for a global market and not just stick to an Indian market. And these are some of the titanium products that we need to be able to make ourselves. On the left-hand side are the aerospace products. One of them is 3D printed, and on the right are medical devices. Again, the same story in medical devices. These are imported. We could easily make them in India and create the pull. The story is very similar in carbon fiber, which is another aerospace material. The vertical bar on the left shows the global production of carbon fiber. In 2018, it was about 90 kilotons, 90,000 tons. And in 2025, it will grow to double, more than double. It will grow to about 200,000 200,000 tons. And that's because people are, and we know that because people are setting up plants in France, in Taiwan, in Japan, etc. And most of this material, carbon fiber, is going to aerospace, but they're also going to wind, to automotive, to sports, to infrastructure, to marine and pressure vessels. And these are pressure vessels that contain hydrogen, the type 3 and type 4 cylinders, which hold hydrogen at pressure and are used for carrying hydrogen in buses and trucks for fuel cells. Look at India. So remember, if you go back one, the global production today is about 90,000 tons and is going to 200,000 tons. India's consumption is 750 tons. It's metric tons. It's not million tons. 750 tons. It's less than 1% of global consumption. And of course, most of it goes to aero. And that too, not necessarily our aero. It goes to make components for aerospace, components for airplanes, for Boeing or Airbus, or even F-16s for that matter. So if you look at the scenario, there is no carbon fiber production in India. There is a pilot plant that NAL had set up years back, and the nation has been trying to upscale it, commercialize it. Hasn't happened. The Indian market is small, and the story is exactly same as titanium. You need to create the market or look at the global market. And again, there's a weak academic ecosystem. I can't see a large, strong group in carbon fiber that can come and aid and help the rest of the value chain from an academic point of view. And again, look at China. China has at least 2 universities, one in Beijing and one south, I forget the name, 2 universities, whole universities dedicated to carbon fiber. So as a nation, we need to create the pull. We need to create the pull by investing in the sectors that use these materials and by having a vision to open up the production to world consumption. We need to have the capability, the technology, internal technology, and the cost point and the quality requirement that will take us across the world. To talk about cost, that is one of the primary reasons why carbon fiber doesn't get popular use. And if you look at the cost breakup, precursor, which is mostly polyacrylonitrile, is most of its is the most part of its cost, and of course labor and utilities form the other big chunk of the cost. So if the nation wants to have a leadership in carbon fiber, it needs to address several issues. It has an advantage in having lower labor costs. So it addresses the 15.3% on the left-hand side. It will lower that. We need a new technology that will address the cost of precursor. So there is a technology which we can favorably use, where you can get carbon fiber from coal tar pitch. There are companies around the world which use carbon fiber from coal tar pitch, and they find they're not very big, but they're not companies that have coal tar pitch per se. But in India, with a growing steel industry, coal tar pitch is a byproduct, and inherently it would therefore be, from a synergy point of view, advantageous cost-wise to have a technology that gives carbon fiber from the coal tar pitch. And we need to be able to have public-private partnership to scale up the technologies that come out. It's easier said than done. Has been tried, but I think we need to have an ecosystem of funding that will enable and encourage such partnerships to happen. Let's talk about it a little later. Let's move on to energy materials. So, as the globe moves away from oil, from carbon-based or fossil fuel-based fuels to electricity, to green electricity and green energy, what happens to India? India is moving from one imported energy source, energy material, which is oil. India, in this table, you can add up, India imports about 40 million tons of oil every quarter. And when you are moving into green electricity through renewables, you'll need batteries, which is lithium, cobalt, nickel, manganese. And of these, lithium, cobalt, nickel don't occur in large quantities in India. So you will be replacing one imported energy material, oil, with a set of three materials for energy: lithium, cobalt, and nickel. Now, all of these materials are not easily available. So lithium is concentrated in Chile and a few other countries. Cobalt mostly comes from Congo, nickel, etc. And most of these you'll see today are dominated by China. China has either bought the mines or bought the resources or have a significant stake in the value chain, in the supply chain of these materials. So we need to be able to take a stake, find a way where we can get leadership in these vital energy materials coming in the future. So here's some examples of how our thinking is going. Search for local sources. So there are lateritic overburdens. So when you have an ore body in the ground, it has laterite on the top, a soil part on the top. And this soil, which is called the overburden, which is removed to expose the actual ore or the coal or whatever, that laterite body has many minerals, maybe in smaller percentages, but it has it's now time to get to technologies that can extract value from lateritic overburdens. We have manganese ores, and it's possible to get to battery materials from manganese ore rejects. There are lean lithium ores in India, and most importantly, urban mining. When these batteries come to the end of life, we should be able to extract and recycle lithium, cobalt, nickel, so that we reduce our dependency on import. So here are a few examples of thought process of how some people are thinking in getting self-reliant in energy materials. So this is about nickel and cobalt, which occur in overburden in chromite ore mines. So there are hydrometallurgical routes which are being developed to extract nickel and cobalt. Coal tar pitch can give needle coke. Needle coke can be used as anode material. Most of the needle coke today is imported from China. So we can replace that import. Gamma manganese dioxide, which can be obtained from ore and mine rejects, and again can be used as cathode material, so on and so forth. So that's the story on battery materials, where we can, if we focus on this, we can reduce significantly our dependence on imports, which otherwise we have to do. So let's finish. I've got 5 minutes. So let's finish with sustainability and environment, which is becoming progressively important across the world as the new investments are pouring in with precondition of the new technologies being green. And our country being such that we are going to grow in steel, and steel has a footprint of CO2. It is one of the hard to abate sectors. So 1 ton of steel gives roughly, rule of thumb, 2 tons of CO2. It is imperative for the sustainability of the steel industry in India, we address this issue. So there are 2 options. As you would know, steel's the most common way of producing steel in integrated steel plants is through the blast furnace route. You make liquid iron, and then it goes to the basic oxygen furnace. And most of the CO2 comes out because of the reduction of iron ore by coke and coal. So one option is to to change the reducing agent in the blast furnace. Although coke cannot be fully replaced, but you can replace the coal that comes in through the tuyeres, the pulverized coal, you can replace that by hydrogen, for example. Or option 2 is look at complete removal of coal from the system, in which case you cannot use a blast furnace. You have to use a gas-based DRI system where there's no carbon, you use hydrogen and reduce using hydrogen, and then use the product in an electric arc furnace. And hopefully that electricity in the electric arc furnace will come from a green source. The consequences are different. If you use hydrogen in a blast furnace, you cannot fully replace the coke. So you're limited in your effect on CO2 to reduction by 0.3 tons per ton. Imagine, just recall, I had said the footprint is about 2 tons per ton of CO2. So you'll come down to about 1.7 tons of CO2 per ton. And of course, it needs, therefore, since the CO2 will be coming out, to go further down from 1.7, you will need CO2 capture. And you will need a technology to use that CO2 that you have captured. And of course, you will still need green and cheap hydrogen to be pumped in through the tuyeres. And in option 2, you will need huge amounts of hydrogen, about 80 kg per ton of steel. You will need electric arc furnace, and with these two, you will have the potential to come down to near zero. So just let's look at what it means. What technologies there could be when you're trying to attain decarbonization, near zero decarbonization. And let's look at a scale at which we're talking. Typical integrated steel plant, about 10 million tons of steel annually, will give 20 million tons of CO2, right? So you will need a carbon capture at that scale. So it could be an amine-based technology. You'll see a photograph on the right-hand side here, which is a 5 ton per day pilot plant, which is being set up in Jamshedpur with amine-based technology for carbon capture. But 5 tons per day is minuscule, of course, but it's a start. There is no technology that is available off the shelf. So it's a start. Or it could be a bacteria-based technology. And there are several bacteria-based technologies doing the rounds. Some are some TRL levels ahead than others, but it's worth a try, and we are trying some of those technologies. Then comes CO2 utilization technology. Once you've captured the CO2, which you have to, what do you do with the CO2? You have to use hydrogen in a Fischer-Tropsch reaction to produce methanol or ethanol. And you can then use that methanol or ethanol as a fuel. But of course, my personal critique on that step is that you're again releasing the CO2 very quickly, because if you use methanol as a fuel or ethanol as a fuel, you're going to burn it to produce CO2. So my preference is point number 2, which is to produce long chain polymers, such as polyethylene or polycarbonate, which fixes the carbon for a longer period of time. But it's more difficult to get there. But we'll get there. The world will get there someday. And the third technology step is production of green, cheap hydrogen. So electrolysis is of course, most popular way of doing that, especially in Europe and US, where electricity is cheap, and especially in Europe, where electricity is green. But it's not feasible in India. Electricity is neither cheap, nor is it green. And if you look at the rate at which we are introducing renewables in the grid, it is rapid, but it is not, even in the next 15 years, it is not big enough to run electrolysis units that will produce hydrogen at scale for steel plants. So we will have to look at other sources. And some of these sources could be using the excess hydrogen from oil refineries, for example, or looking at new technologies that produce hydrogen. I'm going to speak about a few. Yeah, for example, here through gasification of biomass using Oxy Steam Gasification. There's a huge amount of biomass available in Jharkhand, in Orissa, which need to be burned at the end of their life cycle. Now, instead of burning, if you gasify them and get syngas out, which is a combination of CO and hydrogen. That gives hydrogen necessary for the blast furnace or for the DRI, and that hydrogen is green. I'm not. You can still argue that there's a bit of CO2. What happens to that? I will. If there's a question, I'll answer that later. Then there is chemical looping technology, which is at a lower TRL, which is needs a bit of explanation. If you look at the figure on the right, there is a combustor at the bottom, which has air coming in and needs some heat. It oxidizes Fe3O4, or a lower form of oxide of iron, makes Fe2O3, which rises up and comes down into the reducer. The reducer gets fed with the blast furnace off gas, and it oxidizes the CO2. So the CO2 becomes enriched as it comes out, and Fe2O3 gets reduced in the process. And in the next step, in the oxidizer, steam is introduced, which is then converted to hydrogen in the oxidizer. So the iron gets oxidized in the process, and the net reaction is the blast furnace gas goes in and produces CO2 in a concentrated form, some water and hydrogen. And this hydrogen can be used. So this hydrogen can be used in the normal way that we are proposing to use, but this reactor also acts as a carbon capture device. So the pilot is being tried as we speak in Ohio State University in our collaboration. So this is my last slide. So in summary, in order to get global leadership through self-reliance, we need to realize that we have missed certain technologies by not being conscious, not taking conscious steps. The electronics and the photovoltaic technologies and industry have bypassed India in the past, but there are opportunities that are in front of us today, and we really need to take up these opportunities. Otherwise, they will also bypass us. Medical materials and devices, it is so socially relevant. Battery materials and technologies, if we need to be self-reliant in energy materials. Carbon capture and use and production of cheap green hydrogen for sustainability of our hard-to-abate industries. And these can be done if we have, policy interventions and encouragement through government funds, and that will enable collaboration across the TRL levels. Otherwise, it will not happen. It will need academia, research labs, MSMEs, and the large industries to collaborate. And the ecosystem of collaboration needs to be created through a funding mechanism and other platforms. And with this sort of an ecosystem, it is possible to create leadership, global leadership in India with an Indian solution. Thank you very much. Thank you for having me today, and thank you for listening, and it will be a pleasure for me to answer any questions that you may have. Thank you.
Thank you, sir, for your wonderful presentation. We would now like to invite questions from the audience, and we have Rhythm Sarkar, who will be addressing these questions one by one. Over to you, Rhythm.
Hello, sir. Thank you for your session. We have quite a few questions for you. I would start. The first question is, what could be the contribution of process metallurgists in a steel industry during post-COVID situation?
It would be helpful if you also tell me who is asking the question. Then I can tailor my answer accordingly.
It's asked from a fourth-year student from our college.
Okay, thank you. About 15 years back, there was a trainee student in our R&D in Jamshedpur who had come from Jadavpur University. I was then heading the Jamshedpur R&D center for Tata Steel, and he asked me what he should do for his future, and I had told him, you should become a process metallurgist. And he went on to become a process metallurgist. Most of you will know him anyway. I'll not take the name. He's in Canada. The reason I said that is exactly the reason I will give you and pointers I will give you for what a process metallurgist or why a process metallurgist is important, whether it's COVID or not. If you listen to my presentation carefully, you'd have seen that most of the value addition that has come or will come in, say, battery materials, in carbon dioxide, in hydrogen, and in other areas which I've not spoken about, such as in adding value to low-grade ores, etc. You will need deep understanding of how reactions happen, of what the kinetics of reactions are, what the thermodynamics allows, rate constants of the effect of certain elements of certain species in slags, so on and so forth, of effect of sizes, of effect of surface chemistry. It is this knowledge is of absolute importance, and it is vital. Whether you go to urban mining is another way of extraction. So process metallurgists will have a field day in the years ahead in all of these things that I've just spoken about. That is not to say that people in physical, I'm a physical metallurgist, in fact, and one of my mentors became an expert in process metallurgy through physical metallurgy. If he's listening, he will know I'm speaking about it. So he analyzed the blast furnace through the microstructure of sinter and coke, etc. So, but yes, process metallurgists' life will be busy in the years to come. Hope I answered your question.
Okay, sir. Thank you. Moving to our next question. The next question is, why the quality of products that are being produced in India not up to the mark?
This is a chicken and egg story. When it is needed, when it is called for, we can produce the best quality in the world. I mean, if you look at our space program, our atomic energy program, we produce the best quality, whether it is best quality material, we produce the best quality components, we produce the best quality systems in the world, right? If you recall the value chain that I was talking about, it is how pull happens from the market that in a way often dictates how the rest of the value chain behaves. So you will, I remember, you will not know, people from my generation will remember when automotive became important in India. Till early 90s, it was not so important. You had just Ambassador and some Fiat, etc. But as the new automotive companies came in, new versions came in, especially Toyota and the Maruti grew, and then Hyundai and Ford, they brought with them quality standards which were international. They made sure that the local suppliers graduated themselves up to those quality standards. And today, India's quality standards in automotive are the same as in the rest of the world. Yeah. So it is often the market that determines how quality conscious the supply chain is. And in many of the areas, India's market is not mature enough today. The moment we open our vision to being a global supplier, manufactured in India, we will be forced by the global markets to become quality conscious and upgrade ourselves to global quality standards. Hopefully that answers your question.
Okay, sir. The next question is, nitinol, which is a shape memory alloy of titanium and nickel, it has great medical applications, but the nitinol that is used in India is mostly imported from USA and Europe. If India has enough titanium ore, then why is India not producing nitinol?
Yeah. Again, is it a student who's asking this question? Is it a
Yes,
student?
sir.
Yeah. Okay.
Yes, sir.
So as I said, India has a lot of raw material, but India does not make titanium enough. It makes about 500 tons. And most of it is used in defense and aerospace. That too, captive use, because it's as I showed to you, the cost structures are not competitive. So using Indian titanium to make commercial products is going to be difficult till we scale up significantly and become and put all the necessary recycling and value adding processes in place. Till that happens, we will not become such as nitinol or in the medical domain will not happen in India. They will always be imported. It will be more competitive to import them. Unfortunate, but that was the message.
Okay, so over to our next question. Will this pandemic affect job opportunities in Tata Steel? And also, what are the criteria to be fulfilled by a BTech graduate to get a job in Tata Steel?
Yeah, this is one of those questions I was fearing. So your placement office will know what the frequency with which Tata Steel comes to your campus and when it comes, etc. So you have to be in touch with your placement office for that. And of course, Tata Steel will have its cutoffs and its criteria, which, in terms of marks and references and all that, which again your placement office will be able to tell you. But whether Tata Steel, whether we will be recruiting or not, those who have got letters from us, we will honor those letters. In terms of future, I can't predict. It will depend on the business on the business situation, which, as you all read the papers, the business situation today is not good. COVID and all that. But we will honor letters that have been sent out.
Okay, so moving on to our next question. Given the dearth of quality biomaterials in India and the current rise in related research worldwide, how feasible it is for a student in metallurgy and materials engineering to shift to biomedical engineering in India?
So today, the biomedical engineering in India is a small field. If you look at it from a materials perspective, it probably will increase. But again, the world is your oyster, really, as a student. I presume the question is from a student. The world is your oyster, so you can serve India from wherever. If you feel biomedical engineering is your calling, follow your calling. The job will come to you if you follow your calling. So don't follow a job, follow your calling, and some things will happen. There will be a change in the biomedical trajectory in India, whatever. So my advice is not to go by whether there is opportunity in India in a certain area. If you want to be in that area, be in that area.
Thank you, sir. Over to our next question. Does Tata Steel have any plan in the production of titanium, carbon fiber and lithium directly or indirectly?
Titanium we tried. Again, is this from a student or? non-student?
No, sir, it's from professor.
From professor. So Tata Steel spent about 8-10 years on titanium. We had surveyed sites. We took samples from sites in the southern coast of India, in Satankulam area, which is near Kanyakumari. We spent and we thoroughly analyzed the deposits. These are the sand deposits, and we had the flow sheets ready for concentrating the ore, and we had the project ready till titanium sponge stage. But for many reasons, and not necessarily technical, the project could not happen. And we have now given up that project officially. So having spent about 10 years unsuccessfully and having spent money and time, I don't think we will come back to titanium in a hurry. Carbon fiber we are looking into. As you know, we are into composites, but we are into composites on the downstream, not upstream. We are not making the fiber. And currently we are looking at downstream making components from glass fiber mostly and some carbon fiber. So we are toying with type 4, type 3 cylinders for hydrogen. But we will probably not jump into carbon fiber immediately. We will wait for a couple of years to look at what technology to bank on. And parallelly, of course, we are looking at possibility of getting carbon fiber from coal tar pitch, which will be our forte, which will be a great synergy to have. So that's the work that's going on. And I forget what your third material was.
The third material was lithium.
Okay. So we do not have source of lithium, so we will not go to Chile probably to get lithium from the salts. But we are toying with the idea of urban mining, so that we are in the we will to see if whether it is in our business, in our line to extract lithium from spent batteries and recycle them. We are open to the idea of urban mining of lithium. We are doing some work, exploratory work in that direction. We'll take a call maybe in a couple of years' time, after we have more knowledge in that area.
Okay, sir, since we are running out of time, there would be only one question next. The question is, some areas have been highlighted where fundamental research is missing. Titanium and CFC. What is going to be the role of industries in helping academia to go for such research problems?
Yeah, good question. So in the area which is of interest to an industry, that industry will perforce, of course, collaborate, hopefully, if it wants to get into technology leadership from a global perspective. I don't see somebody coming in titanium in India today. But carbon fiber, we are already collaborating with various institutes, as I said, in trying to find out a new way to get carbon fiber from coal tar pitch. So the industries will come up for collaboration with academia in areas of the industry's interest. And of course, this process can be accelerated, can be made stronger by government, by the help of government funding. Yeah, government funding that comes in when there is a collaboration, especially if there is also an MSME attached, because MSMEs are vital in the supply chain and also research labs. So the whole TRL chain needs to be collaborating, and not just academia and an industry. It's academia plus a research lab which has the ability to upscale to pilot scale, an MSME which can develop around that ecosystem, and an industry. And so that will really help. And I think in some of the areas, this ecosystem will come up, but not all. Titanium, I can't see that happening yet. Carbon fiber, unless there is a market pull or market creation, or somebody sees a global market, this will not happen. So at the moment, we are seeing a global market. So we are driving carbon fiber. So I hope that answers your question.
Okay, sir. Do you mind if you have one more question?
I don't mind. It's up to you. It's up to you. Your time.
Okay, sir. The question is, other than government certification process, what else is impeding India in global leadership in new materials production at scale? Is it just plain simple vision?
Sorry, can you repeat that question, please? I missed a few words.
Other than government certification process, what else is impeding India in global leadership in new materials production at scale? Is it just plain simple vision?
It's not certification process. What I meant was enabling processes and funding processes. So if you this will be a long answer. I'm sorry, Professor Rai is already sitting there. And I'll take 2 minutes to answer this question, with your permission, sir. So if you look at countries such as UK, US, and groups of countries such as European Union, they decide on in the areas in which they want to take global leadership. It could be CO2 sequestration, it could be battery materials, it could be whatever it is. They decide 8, 9, 10 areas of focus, and then they set about principles by which they will enable the progress in these areas. So over the next maybe 10 years. So, for example, Europe Horizon 2020 projects were taken in 2010, a 10-year period, and they had graphene, they had carbon dioxide, they had such things. And imagine $2 billion was pumped into just graphene research, right? And similarly, billions of dollars are being pumped into CO2 research. But the condition there is that you create a platform, the authorities who are giving the money and setting the direction and the focus are creating a platform which says industry, academia have to collaborate. The research proposals for getting the funding must be collaborative research proposals. Maybe across country, maybe across the globe, but they have to be collaborative research proposals. They are not proposal from one industry or from one academic on a very focused area. No, it could be competitors collaborating on a particular research project, and many times there are. So our Hisarna new way of making iron, the new technology for making iron, is a collaborative project between Tata Steel, ArcelorMittal, Thyssen. We are all competitors in the market, but for the 50% of the funding that came from the government, we collaborated in the development of that technology. So that's what I mean when I say there has to be a platform or a system or an ecosystem that needs to be created through a funding mechanism that will enable this collaboration and that ecosystem to develop. Sorry for the long answer, but I think it was necessary to give that explanation.
Thank you, sir. We will be ending the Q&A session now then.